This is a question sent in by somebody on YouTube, and it says she spent 3 hours on this in one day, and she wants to get a little help with this. So what I'm going to do first is go to a problem that does not look like this, but is actually, by the time you figure it out, very similar. In this example, Bridget is going to soccer and she wants to be the goalkeeper, but that depends on who the coach is. With Coach Sam, she has a probability of being the goalkeeper of 0.5, and 0.5 is the same as 50%. So in the other problem you saw it listed as percent. If Coach Alex is the coach, then she has a probability of 30% to be the goalkeeper. 6 out of every 10 times Coach Sam is the coach, so that's 60%. And here are 4 questions that are very similar to the 4 questions in the other problem. And the way we're going to solve this is by doing a tree diagram. So a tree diagram looks like this. The first event that's going to happen is either Coach Sam is going to show up to coach or Coach Alex. So Sam or Coach Alex. So that's the first event, and then the second event would be Bridget gets to be the goalkeeper or does not get to be the goalkeeper. So I'm going to put a line over the G to say not G. There's different ways you could write that, but it really doesn't matter. So looking at the percentages, there is, if Coach Sam is selected, there is a 60% chance right here, 6 out of 10, 60% chance Coach Sam shows up to coach, which means there's a 40% chance that Coach Alex shows up to coach. Now think about why that is, because either one of the others is going to coach, and it has to add up to 100%, or 0.4 plus 0.6, 1, the number 1, which is the exact same as 100%. Now, if she gets to be a goalkeeper with Coach Sam, 50% of the time, of 0.5. So likewise, 50% of the time, she does not get to be the goalkeeper. With Coach Alex, she is less likely to be the goalkeeper. She only has a 30% chance of 0.3, and then she has a 70% chance of not being a goalkeeper if Coach Alex happens to be coaching. This probability here is a conditional probability, and all of these 4 are conditional probabilities. The first one would be the probability of Bridget gets to be the goalie, given that we know that Coach Sam is coaching. And then the second one would be the probability she wasn't the goalie, given that Coach Sam is coaching. And then this is the probability that she'll get to be the goalie, given that Coach Alex is coaching. So that's a conditional probability. On step A, it says the question A, what is the probability Coach Sam will coach and Bridget will be the goalie? Well, that probability is going to be done along this line, going up here, Coach Sam, and then she is the goalie. So the way I find that, that's the probability that Coach Sam is coaching and she gets to be the goalie. And that's going to be 0.6 times 0.5, 0.3, or 0.30. So that's the probability she'll get to be the goalie. Now again, what I did was the probability that Sam was the coach times the probability this was that she gets to be the goalie, given that Sam is the coach. This right here is given that is probability that she gets to be the goalie, given that Sam is the coach, is actually equal to this by definition. probability that she gets to be the goalie and Sam is the coach over the probability that Sam is the coach. So if I replace this part with this, I get and notice, so this is all the left side of this equation up here. Here, algebraically, that would cancel out and it would be the probability of she gets to be the goalie and Sam is the coach is the same as the probability that Sam is the coach and she gets to be the goalie. So that's a little bit of what the conditional probability looks like. Question B, what is the probability Bridget will be the goalie? Well, there's two ways she could be the goalie. Either this way that we already done, which was 0.3, or Alex is the coach and the 30% chance that she gets to be a goalie in that case. And that would be doing it the same way. 0.4 times 0.3 would be 0.12. The other two cases, here and here, are not what we want. So altogether, what we want is the 0.3 plus the 0.12, which, if you added it up, would be 0.42, or in terms of percent, 42%. So the probability that Bridget will be the goalie is 42%, and this is important to keep in mind for one of the next questions. C. If Bridget is the goalie, what is the probability that Alex is coaching? So this probability would be, if Bridget is the goalie, what is the probability that Alex is coaching? Well, we know that this here is the probability of she's the goalie, given that Coach Alex is coaching. But the question is asking, what is the probability that Coach Alex is coaching, given that she is the goalie? And if we think about it, what that means is it's the probability of A and G over the probability of G. Well, we had the probability of A and G, that was 0.12, and we had the probability that she's a goalie. We did that just a second ago. We got 0.42, so this is 0.12 over 0.42. That is what my answer is going to be. And if I put that in the calculator, I get 0.12 divided by 0.42, which is 0.28571426, or 2 over 7 as a fraction. As a percent, it's about 28.57% approximately. What is the probability that Bridget does not play goalie? There's actually two ways we could do this. The hard way would be this, which would be 0.3 and then 0.28, and then I add those up, and I get 0.58. But it might be easier to recall what was the probability that she was a goalie. We figured that out earlier, and that was 0.42. So the probability that she's not a goalie, the complement of that, is going to be 1 minus 0.42. Or 100% minus 42%, which is 0.58, like we just did. So those this problem is very similar to the problem that you asked me. The difference here is you have three things that happen in that first step. Event A, event B, and event C. The first thing that happens A, B, or C in your tree. So there's a 40% chance of A happening, event A, which is to request regular gas, 35% chance unleaded gas, and 25% chance of premium gas. It says of the customers requesting regular gas, only 30% fill their tank. So it's 30% that fill it, and then think about what it would be that do not fill it. And basically you build a tree just like I did in the example, and these questions are going to be reminiscent of what I did in the example. So take this, think about it, and if you still have questions, let me know. Now you also asked the person who gave me this question also asked two other questions, but I'm not going to be able to do all three questions today. But if you want further help and you want to be tutored online, let me know, and we can talk about that. My email address, and of course I have to charge a nominal fee, but given that you spend a lot of time on it, it might help you a lot to just be tutored one-on-one. That way you don't spend so much time studying the same few problems. So anyway, thanks for the question, and keep a lookout for if I post another video, but like I say, I won't be able to get to all of your questions today. Thanks for watching.